Good morning, 7th grade. I'm going to go through what we're doing today. We're going to be reading pages 171 and 172. You will be completing a 3D thinking question on page 172. You will complete B on your CER online. We will read through page 173. You will complete pages 174 through 176, and I will go through that before I end the video. And then you will be revisiting your science probe on McGraw-Hill. So let's start with concentrated revisited. Think of a crowded hallway. Because the concentration of people is higher in the crowded hallway than in an empty hallway, people probably collide more often. Similarly, increasing the concentration of one or more reactants increases collisions between particles. More collisions result in a faster reaction rate. When particles are closer together, more collisions occur. Conserving energy. As you have seen, when atoms collide with each other, they transfer energy and chemical reactions occur. Some reactions absorb more energy than they give off, and others release more energy than they absorb. Energy is constantly transferring between the surroundings and chemical bonds. Yet the total amount of overall energy remains the same. The law of the conservation of energy states that even though energy is always transferring, energy is not created and energy is not destroyed. Energy is constantly being reused. In the lab, changing the energy, you observed energy move to the environment as energy was released. You also observed energy move from the environment as energy was absorbed. So the law of conservation of energy is very similar to the law of conservation of mass in that energy is not destroyed, it just changes from one form to another. Life science connection. The laws of conservation of energy and matter apply to both the physical and living environments. Plants store glucose molecules in their tissues. When plants are eaten by animals, energy and matter transfer to the consumer, the one that's eating it. One way energy can return to the environment is in the form of thermal energy given off by organisms. Another way is when plants and animals die, the energy and matter contained in their tissues is recycled by decomposers. Decomposers are animals that eat things that have died. Food webs model how matter and energy are transferred through ecosystems. So you're going to complete this three-dimensional thinking question in the book. Using the figure below, construct the food chain through the food web, starting with photosynthesis. Explain the flow of energy in and out of organisms using the path you chose. So you're going to pick one, you're going to start with the sun, and you're going to pick one of these paths to do the flow of energy until you get to an animal that has no arrows going out, such as the harpy eagle or the sloth. So you will complete this in your book on page 172. After you complete this, you will do evidence B on your CER in McGraw-Hill. What happens to the energy that goes into or comes from the chemical reactions in the hot and cold packs? So think back to the hot and cold packs that we did earlier, and you're going to talk about what happens to the energy that goes into or comes out of them. And you need to give a very good explanation about where that energy goes. How does a light stick work? So let's take a look at this. What makes it glow? Glowing neon necklaces, bracelets, or sticks. Chances are you've worn or used them. Light sticks, also known as glow sticks, come in brilliant colors and provide light without electricity or batteries. Because they are lightweight, portable, and waterproof, they provide an ideal light source for campers, scuba divers, and people in other activities in which electricity is not readily available. Light sticks are also useful in emergency situations in which an electric current from a battery-operated light could ignite a fire. Light sticks give off light because of chemical reaction that happens inside the tube. During the reaction, energy is released as light. This is known as chemiluminescence. 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 Good try, huh? Okay. So a light stick has a plastic tube inside of it. Hydrogen peroxide is in that tube. On the outside of the tube is a solution of phenyl oxalate ester and fluorescent dye surrounding the glass tube in the middle. So when you bend the outer plastic tube, it breaks the inner glass tube. This works similarly to a cold pack where you have to break an inner bag to mix the chemicals. Once the solutions mix together, the energy produced by the reaction causes a release of light. We will not be doing the life science connection. So you are going to do pages 174, 175, and 176. So here, model energy transfers by adding arrows pointing toward or pointing away from the phrases to illustrate the flow of energy during chemical reactions. So in chemical bonds, is the energy moving toward it or away from it? When they break, when they form, is the energy moving toward or away from that? Then differentiate between endothermic and exothermic reactions. So the type of energy, so the reaction is reactions plus thermal energy is products. So notice thermal energy is going in. What type of reaction is this? What is the energy change? And bonds that contain more energy. Then the reactants lead to thermal energy and products. What type of reaction is this? What is the energy change happening in that reaction? And bonds that contain more energy. On your three-dimensional thinking, you're going to read this paragraph and answer the question. For number 4, you're going to look at the image here on the right. You're going to answer number 4. Number 5, create 2 models that describe the unobservable differences between a cold pack and a hot pack. This is specifically talking about the type of reaction that is happening. Where is the energy coming from, or where is the energy going to? Number 6, many gas grills used for cookouts use propane gas to cook the food. When propane burns, heat and light are produced. Where does this energy come from? Then you're going to go online and do Revisit the Science Probe on McGraw-Hill. Make sure that when you go back and look at the choice you made, that you're thinking about, was I right the first time or not? And then say who you would agree with and why. On Monday, you'll be taking your notes for the quiz, and the quiz for this lesson will be on Tuesday. If you have any questions, please let me know. Have a great day.